السلام عليكم ورحمة الله وبركاته. Welcome my dears Prep 3 in Language Schools. قبل ما نبدأ درسنا النهاردة اوعوا تنسوا تشتركوا في القناة وتفعلوا الجرس عشان توصلكوا جميع دروس العام الدراسي 2020 وكمان مراجعات الصف الثالث الإعدادي. Today we are going to talk about the main trigonometrical ratios of the acute angle. There are three main trigonometrical ratios of the acute angle, and they are the sine of the angle, the cosine of the angle, the tangent of the angle. We can say sine as sin, cosine as cos, tangent as tan. How can we calculate the sine, cosine, and tangent of the angle? First, we want to know how can we calculate the sine of the angle. Here we have right angle triangle. If we want to calculate the sine of this angle, try to divide the opposite by the hypotenuse. Cosine of the angle equals the adjacent divided by the hypotenuse. Tan of the angle equals the opposite of the angle over the adjacent of the angle. The opposite side over the adjacent side. So let's start with the first questions. XYZ is a right angle triangle at Y. XY equals 4 cm and XZ equals 5 cm. Find the value of 2 sine x cosine x. First, draw right angle triangle. X, Y, Z. Don't forget that the right angle is Y. After that, we have XY equals 4 cm. XZ, the hypotenuse, is 5 cm. And he wants to get the value of 2 sine x cosine x. Firstly, we must know the length of YZ. So XYZ is a right angle triangle. We can easily calculate the length of YZ using Pythagoras theory. YZ power 2 equals XZ power 2 minus XY power 2. So, YZ power 2 equals 5 power 2 minus 4 power 2. 5 power 2 equals 25. 4 power 2 equals 16. 25 minus 16 equals 9. So, this is YZ power 2. If we want to get YZ, we can get the square root of 9. The square root of 9 equals 3. So YZ equals 3 cm. Now it's easy to calculate the sine or the cosine of x. Look at this angle, angle x. The sine of x equals the opposite side over the hypotenuse. So sine x equals 3 over 5. What about cosine x? Cosine x equals the adjacent side over the hypotenuse, equals 4 over 5. Now, if we want to calculate 2 sine x cosine x, we can multiply 2 by 3 over 5 by 4 over 5. 2 times 3 equals 6, 6 times 4 equals 24, and don't forget to multiply the numerators. 5 times 5 equals 25, so 2 sine x cosine x equals 24 over 25. What about the second question? Sine x cosine z plus cosine x sine z. He wants to prove that sine x cosine z plus cosine x sine z equals 1. Okay. Sine x equals 3 over 5. Sine x, the opposite side over the hypotenuse. cosine Z equals cosine Z. This is angle C. Cosine Z equals the adjacent over hypotenuse, 3/5. And sine Z equals the opposite side over the hypotenuse, equals 4/5. So the right hand side here, sine x cosine Z plus cosine x sine Z equals 3/5 times 3/5 plus 4/5 times 4/5, which is 9/25 plus 16/25, which is 25/25 equals 1. 1 is the left hand side. So we prove that sine x cosine Z plus cosine x sine Z equals 1. Now ABC is a triangle in which AB equals AC equals 10 centimeter. And also we have BC equals 12 centimeter. Draw the line segment AD perpendicular on BC. The line segment AD intersect with the line segment BC at point D. At first, find the value of the sine angle CAD and find the value of the cosine angle CAD and find the value of the tan angle CAD. Okay, draw the triangle. AB equals AC equals 10 centimeter. BC equals 12 centimeter. Then draw AD perpendicular on PC. AD perpendicular on PC. So in triangle ABC, we have AB equal AC and AD perpendicular in BC. So D bisect BC. CD equal DB equals 6 centimeter. Now we can calculate AD easily using Pythagoras theorem. 10 squared minus 6 squared, because 10 here is the hypotenuse and 6 is the side length. We want to get the other side length. AD power 2 equals 10 power 2 minus 6 power 2. 10 power 2 equals 100, 6 power 2 equals 36, so AD power 2 equals 64. If we want to calculate AD, try to get the square root of 64. AD equals the square root of 64 equals 8 centimeter. Now we have AD, we have DC, we have DB, and we can calculate the sine and cosine of the angles easily. What about sine CAD? CAD, this angle. The sine of this angle equals the opposite side over the hypotenuse. The opposite side here is 6, the hypotenuse is 10, so equals 6/10. We can write it in the simplest form, dividing both terms by 2. 6 by 2 equals 3, 10 divided by 2 equals 5, so we can write sine CAD angle as 3/5. ABC is a right angle triangle in B. AB equals 8 centimeter, BC equals 15 centimeter. Write what each trigonometrical equal to the following: sine C, cosine A, cosine C, tan C. Okay, draw the triangle ABC, right angle triangle at B. And here we have AB equal 8 centimeter, BC equals 15 centimeter. Who can calculate AC? Yeah, well done. We can use Pythagoras theory and say that AC power 2 equals AP power 2 plus CP power 2. So AC power 2 equals 64 plus 225 equals 289. So when we get the square root of 289, we can calculate CA. CA equals the root of 289 equals 17 centimeter. So sine C equals the opposite of the sine C, the opposite side of C over the hypotenuse, equals 8/17. What about cosine A? Cosine A equals the adjacent side of the angle A over the hypotenuse, so equals 8 over 17. What about cosine C? Cosine C equals the adjacent of the angle C over the hypotenuse, 15 over 17. The last one, tan C. We can calculate tan C by both sides. Firstly, we can say tan C equals sine C over cosine C. Or we can say tan C equals the opposite side of C, the opposite side for C over the adjacent side. Or we can say tan C equals the opposite side over the adjacent side. So tan C equals 8 over 15. ABC is a right angled triangle in B. If 2AB equals the square root of 3AC, find the main trigonometrical of the angle C. Here we have 2AB equals square root of 3 times AC. So if we say AB over AC equals square root of 3 over 2, well done. So we will draw ABC triangle, and here we have AB, which is expressed square root of 3, AC, which is expressed by 2. If we want to calculate CB, use Pythagoras theorem, we can say CB power 2 equals AC power 2 minus AP power 2, because we calculate here the side length of the right angled triangle. So CB power 2 equals 2 power 2 minus square root of 3 power 2. 2 power 2 equals 4. Square root of 3 power 2 equals 3. 4 minus 3 equals 1. So CB equals 1 centimeter. Now we know CB 1, AB square root of 3, and AC equals 2. We can calculate the trigonometrical of the angle C easily. We can say sine C equals the opposite over the hypotenuse. So root 3 over 2. What about cosine C? The adjacent side over the hypotenuse equals 1 over 2. What about tan C? We can say sine C over cosine C and divide root 3 over 2 by half, or we can say opposite over adjacent. Opposite, root 3 over adjacent 1, which is root 3. Another question. In the opposite figure, ABC is a triangle. Measure angle A equals 90 degrees. So it's a right angle triangle. AC equals 15 centimeter. AB equals 20 centimeter. Prove that cosine C cosine B minus sine C sine B equals 0. We have a right hand side cosine C cosine B minus sine C sine B, and the left hand side 0. Okay, let's start with the right hand side, but before we start we must calculate BC. We can use Pythagoras theorem. So BC power 2 equals AP power 2 plus AC power 2, because BC here is the hypotenuse, the opposite of the right angle. So BC power 2 equals 20 power 2 plus 15 power 2. 400 plus 225, which is 625. We can get BC as the root of 625. BC here equals 25 centimeter. After we calculate BC, here we have the length of the three sides. So we can calculate cosine C or cosine B easily, and we can calculate sine C or sine B easily. What about cosine C? Cosine C equals the adjacent of C over the hypotenuse, so which is 15 over 25. What about cosine B? Cosine B equals the adjacent of B over the hypotenuse, which is 20 over 25. So when we start with the right hand side, we multiply cosine C by cosine B, then subtract the product of sine C and sine B. 15 over 25 times 20 over 25, which is cosine C cosine B, minus sine C. Sine C equals the opposite of C over the hypotenuse, 20 over 25. What about sine B? The opposite of B over the hypotenuse, 15 over 25. Now we will calculate all the operations here. 15 times 20 over 25 times 25, which is 300 over 225, minus 300 over 225, which is 0. 0 is the left-hand side. So now we prove that cosine C cosine B minus sine C sine B equals 0. Another question. XYZ is a right-angled triangle at Z, where XZ equals 7 cm, XY equals 25 cm. Find the value of each of the following. 10x times 10y. The second question, sine power 2x plus sine power 2y. Okay. Here we have a right-angled triangle, but we must calculate the length of the y. We have the length of the hypotenuse and we have the length of one side. So how can we calculate zy? Zy power 2 equals the hypotenuse power 2 minus the power 2 of this side length. So xy power 2 minus xz power 2 equals 25 power 2 minus 7 power 2, which is 625 minus 49. So zy equals the root of 576, which is 24 centimeter. Now we have the three side lengths. It's so easy to calculate the trigonometrical for each angle, x or y. Try to start with 10x. How can we calculate 10x? We must at first know the sine of x and the cosine of x and divide sine x by cosine x. Or we can say 10x equal the opposite side over the adjacent side. So firstly, sine x equal the opposite over the hypotenuse, 24 over 25, and sine y equals the opposite of y over the hypotenuse equals 7 over 25. What about 10x plus 10y? 10x equals the opposite over the adjacent, 24 over 7, and 10y equals the opposite of y, 7 over the adjacent over 24. And when we simplify these fractions, we get 1. The second question is sine power 2x plus sine power 2y. Sine x equals 24 over 25. So 24 over 25 power 2 plus 7 over 25 power 2. 24 power 2 equals 576. 25 power 2 equals 625. Plus 7 power 2 equals 49. 25 power 2 equals 625. Here we have the same denominator, so we can add numerators. So this terms equals 625 over 625, which is 1. Now we calculate sine power 2x plus sine power 2y. XYZ is a right-angled triangle at y, where xy equals 5 cm, xz equals 13 cm. Find the value of the following. A. 10x plus 10z. B. Cosine x cosine z minus sine x cosine z. C. Sine x cosine z plus cosine x sine z. Firstly, draw XYZ right-angled triangle at y. Then you have xy equals 5 cm, xz equals 13 cm. So we must calculate yz at first. Yz power 2 equals hypotenuse power 2 minus the side length power 2. 13 power 2 minus 5 power 2, which is 169 power 2, which is 169 minus 25, which is 144. Now we want to calculate YZ, which is the root of 144, 12 centimeter. So we calculate YZ 12 centimeter, we have XZ 13 centimeter, and we have XY 5 centimeter. If we want to start with 10x plus 10z, 10x equals the opposite of x over the adjacent of x, 12 over 5. What about 10z? 10z equals the opposite of z over the adjacent of z, 5 over 12. So 12 over 5 plus 5 over 12 equals 169 over 60. Number B, cosine x cosine z minus sine x cosine z. Okay, cosine x equals the adjacent of x over the hypotenuse, 5 over 13, times cosine z, which is the adjacent over the hypotenuse, 12 over 13, minus sine x. Sine x is the opposite of x over the hypotenuse, 12 over 13. Sine z equals the opposite of z over the hypotenuse, 5 over 13. Now we will calculate these operations. 5 times 12 equals 60 over 169, and 12 times 5 equals 60 over 13 times 13, which is 169. So this equals 0. Many thanks, my dear. See you in next lesson, inshallah. With my best wishes, Shimaa Saieed.